logarithm function here. So I have -2, h of x equals -2 minus log base 4 of the quantity x plus 1. Now, based on knowledge that we've already done in class with the functional transformations, as long as you knew what the parent of this function looked like, you would be able to tell that this is going to have, let's see, a horizontal shift left 1, it's going to have a vertical shift down 2, and it's also going to have a flip that occurs over the x-axis because of the negative in front of the log base 4. But in order to approach this problem here, let's approach it by trying to think about what numbers would be very useful inside of log base 4. Right? Log base 4 is an excellent logarithm, like all logarithms are, but only particular numbers work well in logarithms. Logarithms cannot take on anything that is negative or 0. So, in particular, let's try to find a few points that go into the logarithm well. Well, I would like to put in the number 1 if I could, because log base anything of 1 would be 0. Since it's a log base 4, I kind of hope I could get a 4 in there. That would be nice, because log base 4 of 4 is 1. And maybe a 16 would be nice. 16 might be kind of large. Let's go 1/4. Because if I could get a 1/4, then I would be able to get log base 4 of 1/4, which would be -1. Okay, so that's going to be my goals. I wish I could get inputs of 1, 4, and 1/4. However, because of the +1 that's located inside of the parentheses here, I can't use the numbers 1, 4, and 1/4. I'm going to have to actually move these to the left 1 unit. So I'm actually not going to use 1, I'm going to use 0. I'm not going to use 4, I'm going to move that 1 to the left, that's going to be a 3. And then I'm not going to use 1/4, but I'm going to use -3/4. Okay? And now using those numbers, I can fall right into the trap that I wanted to, or I guess not the trap, but the actual image that I want. Because if you were to replace 0 into this function for x, 0 plus 1 is 1, log base 4 of 1 is 0, and -2 minus 0 is just -2. 3 plus 1 is 4, log base 4 of 4 is 1, -2 minus 1 is -3, and -3/4 plus 1 is +1/4. Log base 4 of 1/4 is -1, and so you get a -2 minus -1, or -2 plus 1, which is -1. So this graph just simply looks like it's going to go through, let's see, 0, -2, 3, comma, -3, 1, 2, 3, -3, and then -3/4, -1. So let's put -1 there, and if we go to -3/4, -1, we kind of look like that. So our graph appears to be something like, let's draw in that asymptote that happens with the logarithm. It appears as though it's coming up like this on this side, and over here as this. So just some summary information that's interesting here. That means that the domain of this particular function would be starting at -1 and going off to infinity, and its range would be everything from -infinity to infinity. So why don't you try one on your own? Pause the video and see if you can draw this graph. G of x equals -3 plus log base 2 of x minus 1. Assuming you paused there for a moment and tried it on your own, with a log base 2, the numbers that I wish for would be, what, following our similar reasoning to last time, I kind of wish I could get a 0 and a 2 and a 1/2. Now I can't get those because of the -1 is going to cause a shift right 1, so instead I'll use the numbers 1, 3, and 3/2. Replacing those into the function would give you log base 2 of, oh, I don't want 0, sorry, I want 1. Made an error here. I actually want 1, which means that I will actually have to use 2 minus 1 is 1. Log base 2 of 1 is 0, and 0 minus 3, negative 3. There's a 1 plus a negative 3, which would be a negative 2. And then a negative 1 plus a negative 3 is negative 4. So, going into the graph, 1, 2, 3, 1, 2, 3. 2 gives me negative 3. 3 gives me negative 2. And 3 halves, or 1.5, gives me negative 4. So this time the asymptote is occurring right about here. And the 3 halves giving me negative 4 means that the graph is going to come like this. It goes off towards infinity. So here the domain would be from 1 to infinity, and the range would be from negative infinity to infinity.